Hello everyone, I'm Dominic. I'm one of the two inventors of Smart Fusion, and today I will talk about support-free and better downskin surfaces. Reasons to avoid the support structures. We have two reasons, the economical reason and the technical reasons. First, the economical reason: supports are waste. It takes time to design the supports and it takes time to build the supports. And it requires materials. And it takes time to remove the supports, and these points make the part a little bit expensive than without support. Then we have the technical reasons. Supports are sometimes impossible to access, for example some channel, and support can prevent powder removal, which typically needs to happen prior to the support removal. And support leaves marks in the surface and creating inhomogeneous surface qualities and preventing optimal use of bulk surface treatment. Why do we need support structures? We need support structures to compensate the recoil forces. We need a lot of support for the heat dissipation, and we need support for the counteracting internal stresses because of thermal differences in the part. And we need support for steep parts and angles and overhangs on the down-facing areas. And we need support to connect the part on the building platform. On this slide you see a 3D OT image stack. On the left-hand side you see the part with the support, and you see in certain areas that it still gets overheated there. On the right side you see the Smart Fusion part. You see that it's nearly in the perfect condition. Blue is the right temperature, and in some areas where we don't have the support it's still a little bit hot, but not that much. On this slide you see the design guideline for Smart Fusion. You can print holes up to 50 mm without internal supports. Domes with diameters up to 450 mm can be built without supports. It's only valid with titanium, not verified with other materials at the moment. Overhangs from 30 to 20 degrees can be built without supports. 20 to 15 degrees can be built but might require some supports or constraining walls. Under 15 degrees, overhangs can be built with 2 or more constraining walls or supported edges. And horizontal overhangs can be built if constrained by all sides. With the new development of Smart Fusion, we can print support-free like a polymer. In this example, Smart Fusion starts with less power and increases the power by himself to reach the best thermal state of the part. And that's why we need no connection for thermal heat dissipation, and we can print totally support-free. And we are working on this to make it better for other geometries as well, but this is the first result that we achieved with Smart Fusion. Better downskin surface. When building flat overhangs, the heat doesn't dissipate well through the thin layers. As a result, temperatures at the tip can exceed 500 degrees. If we then use the same laser power, the melt pool becomes very deep, as shown here in the example, with a depth of 250 micrometers. This causes the laser to shoot through the downskin, resulting in a rough surface. Smart Fusion detects the overheating area and reduces the laser power in that area, which prevents the melt pool from becoming too deep and keeps it consistent, for example at 150 micrometers. This way the laser doesn't shoot through the downskin and only the roughness from the staircases remains. Downskin roughness comparison. In this example we printed angled coupons with 45, 40, 30, 25 and 20 degrees. One set was printed with standard parameters and another with Smart Fusion. Afterwards, the surface roughness was measured. As shown, the 20-degree angle printed with Smart Fusion achieved a surface roughness from 64 micrometers, nearly twice as good as with the standard parameter. This improvement is due to the fact that with Smart Fusion the laser does not shoot through the downskin. Thank you for watching, and I wish you a lot of fun with the next chapter, microstructures.